Okay, so question 8, part B. Consider fx equals to sine ax and a is a constant. Prove by mathematical induction that fnx equals to a power n sine ax plus n pi over 2, and n is a positive integer, and fnx represents the nth derivative of fx. Okay, so this one we need to prove by the mathematical induction, and for the mathematical induction there are basically two steps. So I write it here. So for the mathematical induction, so the first step is prove the initial condition. And the statement holds. And the second is assume n equals to k. The statement holds. And then we need to prove the statement still holds for n equals to k plus 1. Okay, so for this question, the step 1 and step 2, the difficulty is basically the same, but the second step needs more calculation. So let's start. So for the first, prove the initial condition, that is n equals to 1. So we need to prove fx first derivative equals to what? Equals to sine ax derivative equals to a cosine ax. And for those of you who don't know how to go from there to there, and we just use a substitution method. So that is by chain rule. So let u equals to ax. So sine u equals to u derivative cosine u, and u derivative is a, so equals to a cosine ax. So that is a substitution method. Okay, so now we goes to here. So fx derivative equals to a cosine ax, and by the first one, cosine theta equals to sine theta plus pi over 2. So we substitute cosine ax as sine ax plus pi over 2. And so we see when n equals to 1, it is 1, it is 1, so the initial condition holds. That is part 1. And also for part 2, we need to assume n equals to k cos. So we assume n equals to k. The statement holds. So that is what? We put k here. So f, the k's derivative, equals to a power k sine ax plus k pi over 2. So now we need to consider when n equals to k plus 1. So we need to find the derivative of fkx. So fk plus 1 x, and find the derivative of this one, that is d fk x dx. And that is equals to a times ak cosine ax plus k pi over 2. So from here to here, we just still use a substitution method to make ax plus k pi over 2 equals to u, and similar to this step, and take a out and cosine ax plus k pi over 2. So I just write it here, that u equals to ax plus k pi over 2. So ak sine u equals to u ak cosine u equals to a times ak cosine ax plus k pi over 2. So still a step of chain rule, and you need to know the chain rule very clearly. Okay, so now let's simplify this one. So still by this step, so now we let sit equals to ax plus k pi over 2. So inside the bracket is, we rewrite it as sine ax plus k pi over 2 plus pi over 2. So we use the conclusion of the a part and simplify it, equals to a power k plus 1 sine ax plus 2 k plus 1 pi bracket. So now here is k plus 1, here is k plus 1, here is also k plus 1. So when n equals to k plus 1, the statement still holds. Okay, so now we finish all the 2 steps and we can make the conclusion, that is by the mathematics induction. The statement proven. So that's all for the 8b.